Okay, we'll be looking at Unit 4, problem number 4 in this video. Okay, it says to find the domain of the function f of x equals root x to the third minus 49x. So again, it's helpful to think, if we're trying to find the domain, which is the possible x values, it's helpful to think what would make it impossible. So we can't take the square root of a negative. So whatever's underneath this radical has to be greater than or equal to 0. So that's how we're going to solve the problem, is by setting this x to the third minus 49x greater than or equal to 0. Okay, the first thing we'll do here is factor an x out of the left-hand side. So we have x times x squared minus 49 is greater than or equal to 0. And now we can factor x squared minus 49 because that's a difference of squares. So we'll put x times x is x squared. And then the square root of 49 is 7. So we'll do x plus 7 times x minus 7 to get that to come out as a negative 49 or minus 49. It's greater than or equal to 0. Now, when you're solving an inequality problem, first pretend like it's equal to. So we would set each factor equal to 0 and make sure you do have 0 alone on one side. So we have x is equal to 0. If we put x plus 7 equal to 0, we would subtract 7 from both sides, and we would get x equals negative 7. And when we set x minus 7 equal to 0, we would add 7 to both sides, giving us x is equal to 7. So those are our three critical numbers. When we pretended like it was equal to, it gave us our division points. So we've got negative 7, 0, and 7 that sets out 4 different regions for us: below negative 7, in between negative 7 and 0, in between 0 and 7, and greater than 7. So now we need to test a number from each of these regions into this inequality that we have at the top, the initial inequality. So let's just start with, say, negative 10. It's to the left of negative 7. So if we put negative 10 in here, negative 10 times negative 10 is 100, times negative 10 is negative 1,000, minus 49 times negative 10, so that would be plus 49. That gives us a negative number. It is not greater than or equal to 0, so we do not shade this region. Now we'll pick a number between negative 7 and 0. For example, negative 1. Negative 1 to the third would be negative 1 times negative 1 times negative 1, which is negative 1. Minus 49 times negative 1 would be plus 50. Negative 1 plus 50 is 49, which is greater than or equal to 0. So we are going to shade this region. And since it has a greater than or equal to on it, we'll put a bracket here and here. Then we test a number between 0 and 7. So let's try 1. 1 to the third is 1, minus 49 times 1. So we'd have 1 minus 49 is negative 48. That is not greater than or equal to 0, so we're not shading anything in this region. And then from 7 to infinity, we can pick a number like 10. So 1,000 minus 490 is greater than or equal to 0. So we also shade this region. Now, of all those regions The question is asking what is the least value of X in the domain? So what is the lowest X that we have in what we shaded?
-7.
So the answer there would be -7. Okay, now number 5 is a different kind of a domain problem. There's no square roots that we need to worry about, but there is an impossible situation here because you can't divide by 0. It's impossible to have 0 in the denominator of a fraction. So to find our domain, anything will work except what makes that denominator 0. So to find out what X value makes this denominator 0, we're just going to take the 6X plus 3, and we're going to set that equal to 0 and solve for the X value that makes the denominator 0. So we'll subtract 3 from both sides, giving us 6X is equal to -3. Then we divide both sides by 6. So that becomes 1X is equal to -1/2. So our domain is all real numbers except X equals -1/2. And it asks us, what is the only value of X not in the domain? So we would say -1/2.
So why do we know that that's not the only value not in the domain?
Because you can't divide by 0, can't have 0 in the denominator of a fraction. So to figure out what would make that denominator 0, we set the denominator equal to 0 and we solved for the X value that would make it 0. So that
Okay.
this is the only X value that would be impossible, because it makes that denominator 0. Okay, now finding the domain and range on number 6, we're just looking at the graph and we see the possible X values start at -1, because that ordered pair is -1, 3. The X value of that ordered pair is -1. And over here at the very bottom, our X value is 3 and the Y value is -5. The problem is that's an open circle at the 3, -5. So the graph gets infinitely close to it, but never touches it. So when we're writing our domain, we're going to have to use a parentheses to represent getting really, really close to 3, but not touching it. So our domain is from -1 to 3, where we put bracket -1, comma, all the way to 3 parentheses. And then on our range, the possible Y values, the lowest Y value in any of the ordered pairs along here is -5, not touching it, but up to it. And the highest Y value we can see here, it goes up to 4. So we're going to go from -5 with a parenthesis because it's not touching the -5 all the way up to 4. It is touching the 4, so we put a bracket there. Any questions on how we found the domain and range there?
Just the range. Can you just go over that one more time on that one?
Yes, the range, the lowest value was at -5. Well, it got down, it didn't touch -5, but it got really close to it, infinitely.
Because of the open,
So
right?
that's why we used the parenthesis -5, comma, up to 4 bracket. And the 4 was the highest value that that graph went. It had this curve. You're
Uh-huh.
for the very highest Y value. So that's why it went all the way to 4 with a bracket.
Okay.
So domain is your left and right things. It's the X values on the ordered pairs. The range is your up and down things, the Y values on the ordered pairs.
Okay.